So welcome. My name is Rez Graham. I'm the lead AI programmer on The Sims. So I've been working at EA for about a year and a half now. It's a lot of fun, really cool. So this is about in-game debugging visualization tools. So I've been in this industry for a while, and I've seen some things that are terrible, and I've seen some things that are great. And so I'm trying to consolidate a lot of those things and impart some of the wisdom that I've learned from people who have made incredible tools. And just the things that I've learned, that I've used, that I've hated, and things that I've loved. So I did a similar talk to this last year at the AI Summit, and it got really good reviews. Where people are like, hey, one of the things that I really wish that you would have changed, that you would have addressed, is what are the things that didn't work so well? And so that's one of the things I'm trying to address here. One of the important things is, why do we even need to invest in these debug tools? What's the point? And this is my producer slide for you producers, or decision makers, as to why should we actually spend any money and resources on this when we could just be making the game? Well, I mean, money is the actual reason, right? I mean, a gigantic dollar sign, because it's going to save you time. It's going to save you money in the long run if you can really provide this window into your game. Visual Studio only goes so far, right? So you can set a breakpoint somewhere, and that's great, and it lets you, dig back in the call stack and all this other stuff. But really, it's not going to get, like, if you have one bug that happens every 10 seconds or something, I mean, Visual Studio is not going to be an easy way for you to be able to track that bug. You're going to have to hit that breakpoint 300 times. So you have to have some window into it. There's an interesting thing that I read, and I wish I remembered the author, but it's the, can you teach somebody the game of Monopoly by giving them the source code to it? And the answer is probably not, right? I mean, you're not going to be able to dig through it. So it's similar with debugging tools, is can you figure out what a sim or whoever is actually thinking by staring at source code and by analyzing and doing static analysis? Probably not. What you need is a window and a view into your actual game layer, right? So they provide this real-time window. They allow engineers to really fix, diagnose things, and you can tailor these different views to your specific problem. So that's really important. That's why you want to invest time and money into these debug tools. Very, very important. So there's 5 different things that I'm going to talk about, the 5 different sort of properties of amazing debug tools, right? First thing we want to talk about is game integration. How are you going to integrate this? This is the first thing you have to think about. How are you going to put these tools into your game? Is it in the engine? Is it just right there in the code? Is it like a standalone application that then connects directly with the game through some communication layer? And one of the main things you have to think about as well is code cohesion. You don't want to sit there and have a bunch of like pound ifs everywhere in the code base, because that can be very unwieldy and very difficult to try and rip out. The second thing is extensibility. So we're going to talk about making modular tools, allowing them to grow as your project grows, because your project is not a static entity. It is a very dynamic entity. And so that's going to be very, very important as well. You have to think about how you're going to extend these tools. Interactivity is another thing. We really want to stop making these read-only tools. Making read-only tools is somewhat terrible, because we want to be able to change the game state. We want to be able to actually modify what's really happening inside the game so that we can we can basically have edge cases. We can push edge cases and force them to occur. QA will love you for that. Visualization, so we need the ability to, once we have all this data, sort it, look at different views, remove and add columns, drill down to the thing that you need. That object right there is screwing you over, so you need to like dig into that particular object. Those types of things. So visualization is incredibly important. And the last thing we're going to talk about, certainly not least, and one of my favorite topics, is keeping history in games. So you need to be able be able to walk some logical structure of all of the things that have actually happened during that particular game, all the game events and all these types of things, right? So it's how you can debug these non-deterministic problems. So The Sims had a number of non-deterministic problems, weird, crazy bugs. And I have a few stories that I'll tell about awesome bugs that we found. So we'll jump right in. We'll get started with game integration. So we need to integrate these games, right? I mean, we have to actually integrate these things in. We need to keep it loosely coupled to our game code, and we need to reuse it on other projects. These are like the 3 kind of top things that I think about when I'm trying to integrate something into the game. So the different types of integration really are in-engine and standalone. So what in-engine means is it's kind of like this, right? It's tied to these in-game elements and typically requires custom UI. So this means that you have somewhere in your C++ or whatever particular language you happen to be using, somewhere in your code, you actually have some pound if or something in there, and it's right there in your engine code. You can launch stuff up there. It's directly integrated into your game code. And you can do this in sort of good and bad ways. It has some advantages, such as it requires, such that it can reuse a lot of UI. So on The Sims, we did a lot of our stuff was in-game, and a big part of that was simply because we have a lot of UI to reuse, right? If you've ever gone through any of the options mentioned, tons and tons of stuff. If you don't have a lot of custom UI, then that can, of course, be a detriment. So the other thing is standalone tools. So they're more reusable across projects. They tend to be. But they require a custom communication layer. If you're something like Star Wars: The Old Republic, then I would hope that you have a very robust communication layer. If you're something like The Sims, which is a largely single-player game, you probably don't. So we had actually very few standalone tools on our particular project, but I've worked on other projects where we had tools that would connect directly to the server, tools that would connect directly to the game in some particular way. And one example here is Perforator, which I'll go into a bit later. So these are two cool examples of some things that we have. So what we did is we had these C# pop-up windows. I'll actually just fly through some of these. We had these C# pop-up windows. So the first thing to understand about The Sims, which also came from The Sims 3, was C# was our gameplay language. So we integrated C# directly with the game. And so that gave us a big advantage because it let us use these C#.NET windows, which is very, very cool. It pretty much mitigated any requirement of UI in that case because C# is, especially the C#.NET, is extremely magical for being able to create easy windows. So what would happen is we would, the gameplay code would really just call directly into the dialog or vice versa. And so here's an example, and we have a pound if, which I told you not to do before, of add snapshot score, right? So this adds basically sends a snapshot over to the autonomy window in this particular case. So this is actually an example of something kind of not to do. But you can still do this integration. I'll show you some sort of good and bad things that have happened and some of the cool things that we did. So let's see. There's a magic keystroke, right, that spawned these windows. So it's just, Control-Shift-Z would spawn them up. So some uses for this were AI, sim schedules, socials, situations, all sorts of, Simsy buzzwords. Basically, it all came down to gameplay. So since C# was our gameplay language, it was all the gameplay stuff was done in these C# type windows. We had something else that we used for the engine-y stuff, the more C++ stuff. And so that were these debug panes. So they were 100% integrated as well, and in an arguably better way. So there's custom debug UI that they had, and custom rendering for each debug pane. Again, it was like a magical keystroke that would just open these things up. So the real advantage of this was like our in-engine stuff. So this was for pathing and camera and resources and memory logging and all that kind of stuff. So this is very integrated into the C++ side. And I'll actually go into more detail onto exactly how both of these things were written and pushed into the game layer. So that was our real main approach to it. There was the third thing that we did, which was more rare, where we had Perforator. So this was our standalone performance analysis tool. And we use Perforator much how one might use vTune or something similar. So our communication layer was essentially a data file. That's basically what we did, and it worked actually really well. So basically what would happen is, in the game, you'd run it in performance mode, and so it would dump out all of this data. It would basically log all the data in the script and dump all of that stuff out to this magic data file, which ended up getting very huge. Perforator would then read it and show all of the performance data, which was really cool. We also use things like vTune and other stuff for the C++ side. The real advantage of Perforator is that it had perfect knowledge of the gameplay state. So it's very easy to just, it could walk through C# reflection or whatever you happen to be using. It could walk through and figure out what was happening. That was very cool. And so the data file acted as that communication layer. So we can determine hotspots. We can compare performance of multiple frames, right? We can identify spikes and things. I mean, it's a pretty typical performance tool, and it's something that we integrated outside. Now, The Sims 3 wrote a lot of the tools that we used for gameplay and even for the C++ engine side. I think they also wrote Perforator. That I don't know. And so one of the really cool things, and this is where we talk about reuse, is we were able to use pretty much all of them on The Sims Medieval, which was amazing, right? I mean, a lot of this stuff was already there. I didn't have to write an autonomy window because Rich Evans wrote it for me. So that was really, really cool. Perforator went a step further because we've used it on projects that have no real basis in the Sims 3 code base. We've used it all over the place in the Sim Studio, which is also really amazing. And so that's some of the power that you get from having these tools that will connect directly to. So it's always a trade-off on what you really want to do, but thinking about integration is extremely important. So the results, the things that went well, of course, is that the debugging panes, so the C++ side, were extremely decoupled from the game code. I'll show you specifically how some of this stuff worked and how we created them. But suffice it to say that there was exactly 2 pound diffs, if I recall, for the debug panes. There's one in like sort of global game initialization, which said if we're in debug mode, then yes, go ahead and spawn this thing that'll spawn these windows. And shut down to destroy that manager. Other than that, there was like nothing. It was just this magical one single point of integration, which worked really, really well. It meant that everything was nice and decoupled. We could delete that directory, and as long as that those processor flags weren't there, then I mean that's it. That's fine. They're not even compiled into release mode, so you wouldn't even have to rebuild. So that was nice. And a lot of these tools were reusable. Like I said, we reused most of them. Stuff that didn't work so well, we had a lot of interfaces. So the C# side, there were there was the autonomy window, there was the socials window, there was a different socials window, there was a situations window, and on and on and on, right? So having a single unified interface would have worked a lot better, and we didn't have that. The C# integration didn't work so well in Mono, so a little kind of history lesson. The Sims uses Mono for a C# interpreter, so Mono is just a special C# interpreter. And it's cross-platform, which is great because it lets us ship on Mac and all this other stuff. Sims Medieval is on PC and Mac, and Sims 3 is on like everything. There's apparently an iPhone version, which I've yet to play. So it's all over the place. And so unfortunately, the version that we use doesn't support any kind of .NET whatsoever. So since we're making these .NET tools, in the Mono build, the Mono target build, I mean, they just didn't work. So that 95% of the time, it doesn't matter, but that other 5% of the time was painful. So that didn't work so well. And then there's also the pop-up windows. As you saw with the pound diff that I showed you in the code earlier, they were tightly coupled in a lot of places to the game code, and that's something that also, it got a little messy, right? So if you're trying to figure out, if you're trying to add something to a window, sometimes you have to like dig around and figure out where it is, and there's no like global spot to say, where are all of the places that are hooking into the autonomy window? They're kind of all over the place. So that didn't work as well. Next time, we want to have much more of a unified sort of debugging tool interface. So we want to have, there'll probably be 2, that's what I'm imagining. So there's one for the gameplay side and one for the engine side, right? But they're a unified interface that's easily extendable and easily modifiable. And so the other thing is having a considerable amount of design influence is what I'm pushing for as well. So I'm talking to, there's the lead AI designer basically, and he and I work very closely together in terms of like, what do you actually want to see? And it's surprising what they want to see. You know, there's a whole crazy formula for determining why a sim chooses a particular action versus a different action. And he actually, which surprised me, wanted to see the full formula with each of the sort of different components of that formula mapped out in the AI viewer. And that kind of surprised me, but I'm like, great, because I want to see that too. So that's what we want to try and do next time and what we're actually shooting for as well, and what we're trying to build like now. So that's really cool. The next thing I want to talk about, which is sort of version 2 here, is extensibility. So this is the next step. Once you have some kind of integration strategy, we need to be able to extend these tools, right? Games are volatile. So I'm at GDC all week, which is very cool. I'm really enjoying it here. I'm sure all of you are too. But when I go back to work on Monday, the game that I left last Friday is not going to be the same game, right? They're going to be very different. The games are so volatile. Tools have to grow as your game is growing. They have to be able to be extended and easily move around and all that stuff. Like so many times you have this tools group and they just go into this like little isolated hidden place somewhere in a basement and they make these tools for you and then they come back and it's like, well, actually our game is totally different now. We don't care about these things and we care about these other things instead. So we have to have a way to be able to extend these tools as these requirements change. And so there's a number of ways that we can do that. So one of these ways is we build some kind of framework. So you have those guys, that's great, but they have to build an extendable framework. So you have this template basically where you say, you know, this is what a tool looks like and here's how you can integrate and how you can add things to this tool. That should have as little impact on the game code as possible. So these are like really important things. And so the next layer beyond that is you have this very simple API for extension. So this is a fairly typical component architecture. So if you've worked with like component actor systems and so on, it's a very much the same concept where you're building up, a tool is defined by a set of components that you're sort of building and creating. And so any engineer at that point can then extend these tools, right? So as the AI programmer, I'm probably not really the best guy to write a tools framework. I mean, I could probably do it. It's not, but it's, we have tools guys who specialize in this stuff, so maybe they should write the framework. However, I am probably the best person to write what I actually want to see out of this tool, how I want to display this information, and so on. So I really should be the guy who's writing that particular chunk of it. And if I'm conforming to the specific interface and creating these components, then I can very easily do that, and I'm not messing anything up. So you have this really important communication layer. So these new tools are just simple components, right? I mean, I just created a new component. And here's an example. I mentioned Rich before. This is the autonomy tool that Rich Evans wrote for The Sims 3. And I'm going to give you an example of exactly what we did to extend it. So really what I want you to look at is this thing down here. These are just tabs. And this is a very trivial way to do this, which is great. I mean, easier the better, right? So it's extended through tools, or through tabs. So in our game, in The Sims Medieval, we have this thing called the role system. And it deals with, if I have a blacksmith or I have a knight or whatever, they have to do special things at different times. They also have to, be for quest sims and stuff. It's how we put them on rails is we throw them into roles and they do things. So we should probably have something that lets us see like what's going on with the role system. What are the roles that are being fulfilled and so on. So we could have written a whole new tool that had this whole new visualization, but we didn't. We said screw that, and we wrote a bouncer tab. And so there it is down there, and that was really cool. And so I click on this bouncer tab and I see that I have, a bunch of sims in world and all this other stuff. Like, we were very easily able to just, C# magic, we just dragged a tab down there and we extended all this stuff out. So that was really important. The other thing that's important, if you notice, and I'll actually jump back here, you notice that if I'm looking here at this is the scoring, so this person is scoring make food and view objects and all this other stuff. If you notice here, it's almost exactly the same as here where I'm saying roll executioner, schedule executioner, and so on, right? So that's really important because what we had was this custom data grid view control. So we created yet another component that was on a lower level. It's an onion that you're basically wrapping. So at the lowest level, you have these reusable components like these grids. I didn't have to write this grid. This grid was there. I just dragged this grid over and magic happened. So you have these custom data grid view controls, and as many as you can create, right? These little custom widgets that you're creating that you build up. And so these things form the inner core of your onion. And then the next outer core is sort of like, in our case, these tabs. And then outside of that, you can layer it as much as is appropriate. And so you're building things up. You're building this like atomic language of these atomic parts, which is very cool to be able to do. Because then a designer can create a tool, right? They just drag and drop different things. And that's sort of my perfect world, but we'll see if we get there. So new components, right? Here's an example of how the role tab was actually added. So as I said, the autonomy window was a C# thing. It's just a .NET window. So a game programmer would write this tab extension, would create these hook functions. So here's a few of the ones that we created. I think these are actually the only 3 that we created for the bouncer tab. So we create bouncer list columns, which creates creates the columns in the data grid view control. We have the refresh bouncer tab, which will refresh it. And then we have the actual creating the detail string for each row. And so the window itself, the autonomy window, is refreshed on these timer cadences, which tend to happen about once every second. And so what you'll see is you'll have the window, and then it'll refresh every second, and it'll sort of update the scores and everything. So that was basically our refresh bouncer tab was like our update tick. And so that we would just, on that update tick, all we do is we go into the role system, we say, OK, give me all this data, and we just blast it out to the window. And so it was that simple, right? It was a simple interface. We added these tabs. These custom UI widgets were very easily reused, and almost all of those tabs, by the way, use that data grid view control, because that's really what you want, is you want a big grid of stuff. And so that was really cool. That worked really well. Let's look at another example. This is more of a C++ example. We have this thing down here called, this is the scene profiler. This is one example of our sort of in-engine stuff. So this is showing our rendering, and it's basically like, OK, here's the translucent pass, here's the opaque pass, here's the water effects in the trees, and so on. So it's showing you like percentages of how much of the frame and stuff it's taking up. Very cool. You can't really see it, but up there it says debug input active. So it's basically spawned in a similar way to how it spawned, how we spawned the autonomy window. So you hit a magic key, in our case it was U, and then as you hit left and right, it spawns, it tears down a window and then spawns a new window. It just creates a list of these things, which made it very easy. So the debug pane architecture, and I promised I would show it, so this is what it looks like. For those less familiar with UML, what we have is we have a custom window base class. Inheriting from that, so a subclass of that is debug UI pane, and a subclass of that is your concrete debug UI pane. So the custom window is our normal UI system, basically. It's just one of the many windows that inherits from our normal windows and stuff. It's just our normal UI system. The debug UI pane is a special thing that you inherit from so that you can attach hooks and so on. And then, obviously, you write the concrete one. So basically, you write this subclass. So there's just a simple example of the scene profiler one. You have to declare a new factory, and then that's actually it, right? So you just have this extra little case thing that declares this factory function, which generates your actual window. So the debug UI win proc thing that you're seeing there on the left acts very similarly to how you would do like Win32 messaging. So it's like a Win32 type message pump. And so what it does is it gives the debug UI panes updates, and it also is the thing that's responsible for actually creating your window. And so that all happens in that one little magic pound if that I told you about in the global initialization and, again, in the global teardown. It creates a list of all of these factory functions and then just calls them as you're hitting the right or the left key. So that was extremely simple. It was very decoupled because none of these concrete debug UI panes, or I think even the debug UI panes, the debug UI WinProc, none of that stuff actually even exists in the debug or in the release build. So that's nice. So the results of this, right? The stuff that went really well. It was very easy to create new tabs and panes. And we did quite often. Custom controls like the data grid view control worked incredibly well. That was really, really cool to be able to have this thing that we could just drag and move around. And a lot of these tools were used on The Sims Medieval. I mean, we stole a considerable amount of tech from The Sims 3, which was amazing. And some of these tools are even being reused on new projects that we're doing. So it's amazing. It's really cool to be able to do that. The stuff that didn't work so well is that we didn't have enough of these. The data grid view control is one of the few sort of custom lower level controls. What we really need to do is we need to create like an entire toolbox of these things, different special types of things that we need, different specialized controls. Especially if your game doesn't have the ability to do things like have C# magic windows, you're probably going to want a lot more of these types of custom controls. And that's something that we're going to be pushing for in the new projects ahead. And not all of these tools can be extended, so we have things like the socializing tool, the other tools and stuff that we had, the situations window I think was another one. And so they didn't really have this extension built in. And so the ideal thing to do would be to sort of roll them in and conform them to this global interface, which is what we really want to do. And so, again, we're moving more towards being able to do that. Next time, as I said, more custom controls and more custom views and things. So that's really where we're trying to push and where we're trying to move towards. So the third thing that I want to talk about is interactivity, is the ability to write to the game state, really. So it's how you can debug these problems of game state. And actually, I have a really great example, and this is also gives love to the testers here. There was a really horrifying bug that the testers found once. I'm trying to remember what the actual steps were. It was something to the effect of, if a sim has very low energy and so they're going to sleep, and then they starve to death while they're sleeping, and as the Grim Reaper is coming to take their soul, you quit the quest that you're on with that sim, and then start another one, then the Grim Reaper is like locked there and the sim is deleted. And the Grim Reaper doesn't know what to do because I think it actually throws an exception because the sim is basically deleted out from under the Reaper. So it's like, I mean, how are you even going to debug that without being able to write to your game state, without being able to tweak those values? I was able to repro incredibly simply. I dragged energy down to -95, and then the sim went to go to sleep, and then I dragged hunger down to -100, and then, I mean, I was able to reproduce it in 30 seconds. So you have to be able to have these tools write to the game state. Really, really important. So some design considerations. So they should be as interactive as possible, right? So it's easy to debug. It needs to be easy to debug non-trivial game states. So the sim mode of failing, which was an example I just gave, but that's also somewhat a Sims-specific thing. So other examples that work in basically any game is spawning objects, right, and triggering events. So if you have a first-person shooter or something, and you're trying to debug, if you have a quest or something that's like, okay, I have to go forward and I have to shoot this guy in the face, and then I have to go and shoot this other guy in the face. Well, if I shoot the second guy in the face first, then maybe the trigger doesn't really happen for the first guy, and that's never going to get triggered. And so you have to have the ability to be able to debug like what's actually going on there, and be able to say, okay, I just need to get to like I need to get 3/4 of the way through this level. So I'm just going to, click this thing that's just going to like spawn all these triggers and teleport me to the place that I need to go, right? And same thing with spawning objects. Like I've done all these triggers, but this thing isn't spawning, or maybe I just need to debug some interaction with it. These are all very important things. And this is a sort of an odd thing, but being able to dump the current state with a single button press, that's actually really important. And I didn't think it was important until I started using it. So that's really the key. A number of the tools that we used on The Sims, if you hit a button, it like opens up Notepad with basically a whole bunch of stuff. And so that's especially important as things are just like scrolling by and changing and all that stuff. I mean, it's like, okay, weird state, click a button. Especially if you can have that into your sort of release or whatever build that your testers are doing. They can say, okay, something bad happened. Press the magic button and send that to engineering. And so then engineering gets like, here's the state of the main objects in the game. We can kind of see what's going on. So debug tools can also help these designers, right? They can live edit things in the game, as I just explained with the thing. That can also be used for tuning, right? So hunger is a great example. Let's drag hunger all the way to the top and play the game and see how it feels until my sim wants to start eating again. And so we have sims generally eat about twice a day, and so that feels about right. But remember that tweaking and tuning are two very different things. So tuning means I'm going to balance a bunch of parameters in some gigantic tuning tool. Tweaking means I'm in the game and I want to tweak some like small value somewhere, or I want to change the game state somewhere. These are two very different things. So I'm not suggesting that your debug tools should replace your tuning tools, because your designers will probably hate you. But what you should have is some way to reload that tuning on the fly so that you can reload things and keep things going, right? So on The Sims, what we do is we have whenever tuning changes, if we go in there and change tuning and re-export and all that stuff, we just have a small little cheat console thing that just says tuning.reload, and then it sits there for a while reloading a whole bunch of XML, and then all of a sudden you have new tuning and you just restart the interaction or whatever you're trying to do. So that's really important to be able to do. And I'll show you an example of what we did. This is actually how we got this stuff to work, right? So we have here on the left, these are our commodities. For those unfamiliar with The Sims, commodities are things like bladder, hunger, energy, the things that the sim actually cares about in terms of how they score interactions in the world. And so all you have to really do, I mean, you can see bladder is at negative 25.5 here. I can drag that anywhere I want. The slider is also updating every second as it refreshes, but I can move that wherever I want. So if you click on one of these things, I've accidentally killed sims by dragging their hunger over using the scroll bar or something, which makes me probably a terrible person. Another example is events, right? So this is a different window. This is the socializing window. What I'm actually trying to do is draw your attention to this Know Everyone button. And so in the game that we're working on now, which is unannounced, I wrote the relationship system, for example. And I can tell you that one of the first cheats you ever write is Know Everyone, so that you can debug all of the little like romantic socials and all these other little things that you have to have like huge relationship for. So you know what? No, just Know Everyone. I don't want to go through the 5 minutes of introductions and all this other stuff. So that's really, really important and very cool to be able to do. So we have a number of these types of things. This is just a single example. So I'll give you another example and give some love to the C++ guys over on the system side. And it looks small. Can you see that? Yeah, okay, that doesn't look too bad. So the thing on the left is basically a bunch of kind of drop-downs of different things that we have. What we're looking at right now is the camera, and those little sliders that you see there, they do a number of different things. Examples are like pushing the far and near planes out, right? So the camera frustum, you can push the far plane as far as you want. I mean, that means that, hell, a designer can change your frustums, right? So a designer can go all the way out and pull the camera as far as it'll go, look at the furthest awesome thing, and then push your far plane out as it needs to go. And then he can fight with the graphics programmer and says, no, we can't render that many triangles. So that's really important to be able to do. I mean, you can do this stuff on the fly very easily. And that's it. I mean, what do we want our camera frustum to be? There it is. So that is very important. Oh, no, that's the thing. OK. So what went well? Well, it was easy to set these edge cases, as I said, for that bug, what was happening there. So things like death bugs and AI motive failures are, for the Sims, things that we often that were often the edge cases that we had to deal with. I worked on an adventure game called Rat Race. And in Rat Race, one of the things that we had to debug quite often was, so since it was an adventure game with things like dialogue trees, so we had a tool that let us literally just have a conversation in the tree. As you expanded different things, you were having a virtual conversation. And so if something failed, then you could say, oh, that's the thing that failed, and debug that and say, OK, what are the conditions that it failed on? So that stuff is really important. So these are edge cases that are a pain in the ass to debug and that you almost can't debug with just pure Visual Studio or whatever you're using. That's really, really important. Right? And some of the stuff that didn't work so well is that we didn't have as much cohesion in editing. You notice I had to show you, 3 different tools to show you 3 different ways that we edited things. So that was something that didn't work as well. It's something that we're trying to fix, again, for the future, so that we have one thing. We want more interactivity. We want to be able to create more events, and we are doing that, where we have a very, very simple cheat console command interface now, which makes it trivial to write like console commands in our new game. And so that's really cool. Same thing with debug logs. That's also something that we are, in fact, actively working on. I think that's something that I'm supposed to do when I get back to work, is create more debug logs and actually dump this stuff out so that testers and designers and stuff can say, my sim is broken. And I go, OK, that's terrible. Send me the debug log. And so they've already started doing that, which is amazing. It's really, really powerful to train your designers and your testers to be able to use your tools, your debugging tools. It's incredibly powerful. And actually I have a great example of that a little later. So now that you've done all these things that I've told you to do, you've created this cool custom interface, any engineer can extend and make these tools. Now what you end up having is you have just too much shit on the screen. I mean, there's just so much stuff. You just have this incredible clutter of things. So maybe you're trying to ask yourself a question. How many guards are there? Well, I don't know the answer to that. Let's try and figure that out. Here is an amazing, so some design considerations and stuff. I have an amazing screenshot for that. Visualization tools really get very, very cluttered as soon as they start getting any level of advancement. And so that's actually why you end up getting that pattern of having like 20 different tools that you have to spawn. And an interesting story is that when we got the Sims 3 engine to start working on Medieval, there were actually certain tools that we didn't know about like until 6 months into the project when there was actually a period of time where I started going, OK, Control and then every button, and then Shift and then every button, and then Alt and every button, and then trying to do combinations to find tools, and I found like 3 tools that nobody knew about. So that might also be a communication issue, but still, that's very important. Users need to be able to control their view of the data. So this isn't just about it's really about trying to not just like column sorting, which is very important, but like turning tools and columns and things on and off, especially for visualization stuff. I mean, like a routing path or something. Maybe I only care about this Sim's routing path and routing data. Maybe I don't care about all routing paths generated everywhere in all, 75 Sims in the world. And so some ways to reduce clutter, of course, are being able to turn different views on and off, being able to enable and disable columns and sort by columns and filter logs and all this other stuff. So these are very important. So here's my amazing screenshot. And so I actually have I took the screenshot, so I know. But I mean, if I didn't take the screenshot, I would have no idea what area of the world I was even looking in. Although a terrifying thing happened. So I gave this talk at EA to a bunch of my coworkers, right? And there's one QA guy in the room. And he looked at it and he's like, it's the throne room. He just knew, and that was really terrifying. And it is the throne room, in fact. This is our throne room with every single, and this is just routing. Every single routing tool turned on. And so let's turn some of these off. And we can see the throne room, hooray. Now all we have are paths, and we have routing slots turned on. So there's a yellow line that you're seeing there. That yellow line that's coming from outside going to the foot of the throne there is a path. So the sim is going there. And they're probably going to petition the king to put his neighbor's sheep on fire or something, right? And so the other one, you can see another one kind of towards the bottom of there's the woman kind of pathing down. And so really it's these buttons down here. So these buttons are the things that turn things on and off. It's literally simple toggles. Some of them have like 3-state buttons. But really it's just simple toggles. I mean, that's all it is. It's like, I want to show this piece of information. So I add a new button, and now we have a new toggle for this piece of information. I want to show a new piece of information, and so on. Like, maybe I don't care about like the bounding spheres, or maybe I don't care about different like bounding box things. Maybe I don't care about whatever else some of these other tools are. Lot checking things and all that stuff, right? What was the other thing I wanted to show you? Oh, and so the information at the very top of all of this stuff is like a history of all of the routing different requests. And that's something really cool. Keep that in mind, because we're going to talk about that a little later. So visibility design considerations. So usually it's a single object, right? That's a cause of your issue. Like, there's an object right there that might be the cause of all of my problems in this world. And so what we do is we take this object, and we need to be able to somehow like drill into it and see, what is this object doing, and why does it hate me? So we do this with so we do this by drilling down into that object, right? And hopefully you can actually do that in game or something similar, right? You should be able to like Shift Control Alt spacebar click or something on the object, and it should be able to like dig into it. On The Sims, if you, and I actually don't remember the key press exactly. There's like some like Alt Shift click or some right click or something on a Sim. If you did that, it would actually break into that Sim's thread, and you can see exactly what they're doing. You know, hopefully they're running an interaction or running autonomy or something. But really, like that was incredibly powerful. It's like the Sim's doing nothing. Click. Oh, okay, that's what he's doing. He's broken somewhere, and so that was really powerful. Especially when you have 70 Sims in the world all running through the same code path. So here's a great example, right? We have a Sim right there. What is this Sim doing? I have no idea because she's just standing there, right? I don't know what she's actually doing. So maybe I'm curious what she's doing. She has a name. Her name is Kira. So maybe that can help us in some fashion. So in the autonomy window, we have a little drop down. And you can click on the select Sim, and you can just go, so you write select Sim, and then you can just go right there, and you can select her. And in fact, right here, and can you see it? Yeah, that's pretty good. I can actually see that the thing that says local, which means she's running local autonomy. What that actually means is she's deciding something to do in the area that she's in. And then the other thing, which is ask how fare thee, which is a social. So she's trying to talk to somebody. That is exactly what she's doing. If I click on her, then all of a sudden the AI window is now updated to what she's doing, and I can actually see all of the different things that she's scoring. And so there she is. This is her thing. So she wants to socialize. Mostly I'll socialize. She wants to listen to a Pateran evangelist and send personal letters and whittle, because our Sims love whittling, and so on. So lots of different things. So some design considerations, further design considerations for visibility. This one I think is, and I've seen this in tools not actually happening, which is sort of bad. But you need to be able to let your users sort data. I mean, it seems such a small thing, but it's incredibly important when you have 30 columns of things, and maybe you only care about like failed interactions or something. I mean, you need to be able to sort things. Color and syntax sort of highlighting, very important. I mean, we all use so there's Visual Studio, there's Eclipse, there's Dakota, there's, I don't remember the one that is there for iPhone, Xcode. So all these things, they all have one really big thing in common. They all highlight your syntax for you. They all, all of your keywords are one particular color, and maybe functions are another color, and so on. So why we're not doing that in tools more is beyond me. We need to be able to see based on color very easily what's going on. And then logs, which is a pet peeve of mine. So you guys from smaller studios who may not be able to build gigantic visualization tools, you still have logs, right? And so it's really easy to miss something when you have thousands of lines scrolling past you. So being able to color code that stuff, it's, if you're relying on the fact that you know what the shape of an exception looks like the shape of the text, that's terrible. My friend Mike McShaffrey actually has a great story which I'm going to shamelessly steal right now. Well, he worked on Ultima Online, right? And he told me that he could see what was going on in the system by the shape of the text. And as soon as you have something like that happening, you really should invest in color coding or something similar, so that you can see exceptions should be red and maybe warnings are yellow and all this other stuff. And by the way, one button should be able to dump all of that so that an engineer can actually see it and see what's going on. Data sorting, right? I mean, we have columns. So we got away with, we got it for free because we had C#. But you guys probably don't, so you should be able to click a button and do a very simple quick sort or something to just sort the data in some reasonable way. In our game, the last chosen interaction is always colored green. So I can have an entire screen full of interactions that are going on. And the green one is the one that they're doing. So Nurse Leia is attempting to scrub a floor somewhere. And if I go and look at Nurse Leia in-game, she should be doing one of two things. She should either be scrubbing the floor, or she should be routing to the place where she's going to actually be scrubbing the floor. If she's not doing one of those things, then something is probably wrong with the tool. And then red, so anything that fails a test. The way that Sims AI works is that we have sort of early out tests. For example, I can't go to sleep in a bed that somebody else is already sleeping in. That's an in-use test, basically, that would fail. I can't try and kiss someone who I'm not romantically involved with or have reached a certain point with, and so on. So these are tests that all fail. Examples here, you can see at the very top of this little red box, this particular sim, Nurse Leia, is not choosing to collect object at herb plant spawner 2, which means she's not collecting herbs at that particular location because her skill is too low. And so I should never see this bug. And this actually isn't a bug. This is by design. But I should never see, if this were a bug, I would never see this, which is amazing. Because a designer can use this exact same tool, and they did, to look at that and say, oh, I forgot to tune this to this value. So being able to have these tools means that I don't have to do work, which is amazing. So that's very, very cool. That's a prime example of how it will save you money, because engineers are very expensive if I have to go and figure out what's going on there. So we can have different views. So here's a sim. Why did they choose this particular thing, right? And so there's a thing right below it. Basically, they're choosing to read a particular book at a bookshelf, or they might read this other book at that same bookshelf, or they might view objects at a different bookshelf, and so on. And so you can see the scores here on the left. I should probably remove that there. So you can see the scores here, 3.5, also kind of 3.5, also 1.3, and so on. So it's not just a pure weighted random, or that would be silly. So what we do instead, we can see, this is the exact same view, but it's just a different view. Right? Or it's the exact same data, it's just a different view. There's the probability distribution curve, right? If I remove this, you can see it a little better. So you can see exactly, these are the only things they were even actually potentially going to ever do, were those three things, the top three things in that particular case. And so you can see how they're distributed and why they chose that particular object. So it was really easy to debug a single sim. If I need to figure out what's going on with a sim, I can usually figure it out. The tool filtering and data sorting and all this other stuff, some of which we got for free, some of which we didn't, was also very, very cool. It allowed us to really grab what we needed. The stuff that didn't work so well is multiple sims, and that's always kind of tricky, right? So I want to compare two sims. I want to see how this sim is scoring versus how this sim is scoring, and there's no easy way to do that. Or I want to see, what this sim's interaction queue is versus this sim's. So, what you end up doing is you're toggling between them and just quickly looking at what they are. There's no easy way to do comparisons, which is something we're trying to fix. And then, as I said, the autonomy window is constantly refreshed, and that got to be a little painful. So the reason why that got to be a bit painful is because if I have a whole bunch of data, and so I scroll down, and then the autonomy window refreshes, now I'm all of a sudden at the top of my window again, which we solved with a checkbox that says, if this is unchecked, don't scroll the window. So that got to be kind of a pain. That was easy, but again, something that we look at and we're going, okay, let's fix this. Let's move forward and fix these things. So we want the ability to create custom views, and that's something that I think is potentially really powerful, especially if it's a visual kind of language where you can drag and drop different things, show different columns or hide them. Windows Explorer does this, right? I can go to Tools, Window Options, or whatever it is, and I can just check which columns I want it to display. And so we want the ability to be able to do that as well and be able to just sort of mix and match different things and have designers and even producers be able to do these things. One thing that I kind of want is the ability to tag data rows. So if I have a whole bunch of data that's just all there, I just want to be able to say click, and this row of data is the actual row that I care about. So as the thing's sort of resorting, it'll show I can just see that one row of data. That's really important too. And then finally, as I said before, object comparisons is a big thing that we're trying to fix and do. Okay. So the last big thing that I want to talk about is history. And history is really, really important. And I have stories for how this basically saved our ass on multiple occasions. So your game state is really non-deterministic. Even if you have a deterministic game, it's actually still non-deterministic because you have bugs, right? So your game state is always pretty much a non-deterministic thing. You need to be able to see that things are going to happen as you expect, or even as you hope. So you have to be able to walk backwards and see what's happening. So even logging and all this other stuff is very important, but really, it's the classic thing of I have a sim standing in the middle of nowhere. I can look at his call stack and I can see that he's doing nothing, and so that's great. I can look at his autonomy window and I can see that he's not thinking about anything. That doesn't actually tell me how he got into this bad state. Usually it's something further down. It's history that's, 3 interactions ago he made a poor choice in life, and now he's in the middle of nowhere, lost and afraid. So some design considerations is, it all boils down to basically track everything, right? Anything that can change your game state, you need to actually track. So especially if it has some non-deterministic thing. But even events, the example that I gave before of the first-person shooter where I shoot one guy and then I shoot another guy, but if I shoot them out of order, then something can break. A lot of times QA is not going to tell you that. A lot of times QA will say, oh, this thing just didn't work. And they may not tell you exactly what happened. But if you step backwards and you can see, oh, I see you shot them out of order. Maybe there's something broken there. So AI, game events, pathing, simulation updates, all these things are very important to be able to change. So every state, they subtract some kind of ID timestamp, the owning object maybe. all sorts of different things. I'll actually show you what we tracked in a moment here. So you want to copy everything, right? You don't want to just have the object itself. Really, what we mostly did is we copied strings. Like we're only displaying the data. We don't need to copy the data, the actual data itself. We don't need the actual object. So then we built up a stack of these things. Allow your tool to walk the stack, just like Visual Studio. I mean, this is all fairly simple stuff. And then here's an example that I promised I would show you. This is the attempted interactions window, which is an amazing window that came to us in golden hands from Sims 3, and so we love them for that. So this is the stuff that we were storing, right? So there's string, there's target, a string for the name, a string for the target, priority, all these things. So these things, very, very simply, just strings of the data that we're actually displaying. Fairly lightweight for the most part, except, of course, it's all in a debug build, so who actually really cares how heavyweight it is as long as it works. So I'll give you a few examples. The first one is routing. And so I told you to remember that we had this little chunk at the top. Well, this is actually every route that's been performed either since the dawn of time or through some tunable value. I think it goes down to like 100 or so. So it shows you a whole bunch of routes. And you can just see, like, oh, look, that one was canceled. And in fact, I did that on purpose so that I'd have something interesting to show in that column. So you can see what every sim did. You can see their start position, their goal position, all these other things. And I can see all of the history of these things. I can go to a particular thing by using these buttons. So I walk through the list basically using these buttons. And here I can jump to the start and goal node. So I can actually walk through and see the exact path that sim has taken. So I can just walk through the list and say, OK, this sim went from here to here. And I think it actually jumps the camera there, which is very cool too. Another example for AI is this little history slider. This history slider is super important and is incredibly cool. So we have a doctor, and we want to know what he's doing or why he's particularly doing something. Maybe there's a sick sim, which is what doctors are supposed to treat, sitting there, and you're like, did this doctor ever actually treat this sim? Well, let's find out. Because right now, he's certainly not. He's researching at the archives, which may not be what we want him to do, but maybe it is. So we're at the top of the stack right now, because it's all the way to the left. So he chose research, and so we jump backwards. All we do is move the slider backwards a little bit, right? So it's up the stack. Well, he did want to treat somebody. It's bold because it's something that he wants to do, right? And also, the score is 123, so that's kind of a lot. Great, but did he actually do this? Well, I don't know. Let's see. This is the attempted interactions window, which is actually my probably favorite window. And so this is every interaction this sim has ever done since he was instantiated in this particular case. Again, a tunable value on a store, millions of these rows. And so did he actually treat the sim? Why, yes, he did. At 4:40, sim time, right? Treat Flavius Brenner. Success. So he has successfully treated this sim, which means OK, researching at the archives is probably fine. The other sim probably just hasn't finished this interaction, hasn't left yet. So it's really cool to be able to walk backwards in time and see these things. And in fact, I have two amazing stories about that. And since I started early, I actually have time to tell them. So the first story is the tech director, Darren Giles, really cool guy. He, towards the end of the project, he's like, we need to have engineers soaking the game. So we should actually, soak the game, maybe in the debugger with, all the exceptions and stuff, to auto log out to a special file, which you should also do, so that it doesn't break your game completely. And so just, everyone do this. And so we did that. And so the next day, you soak it overnight. And the next day we come in. And so we do our gameplay stand-up. And we're like, yeah, everything went fine, except that my sim died. And then the next guy's like, yeah, my sim died too. And everyone's sim is dying. They're all looking at me. And they're like, Rez, why are our sims dying? And I'm like, I don't know. My sim lived. And so he did. He lived, and it was great. So QA is like, we don't know what's going on. And I'm like, OK, well, let's reproduce it exactly how someone else had it. And so I reproduced it that way, and I just let it soak. And so what I did, I had to set a breakpoint in the death code. So if anybody died, then that was going to happen. And so that made it so the sim was still existing there. And so then what I did is I just let it soak. And so it soaked. Sim died. Great. So I let it run, paused the game, so they're in the middle of the Grim Reaper coming and taking their soul and stuff. And so then I went to the attempted interactions, and I see, expire. And then immediately below that, I see practice indefinitely. I'm like, So long story short, what was basically happening is that the person who had implemented practice indefinitely circumvented a magical little chunk of code that checked to see if a sim was starting to motive fail. Typically what happens is if you're motive failing, your sim breaks out of whatever interaction they're doing and then immediately tries to solve for what you're motive failing for. And so the person who had implemented that had circumvented that code. It was a relatively simple fix. We were able to see exactly what was happening, and we were able to fix it actually trivially. It was really simple fix. It was like, less than a day. And so, so the sim, what was happening is the sim was working themselves to death, which, we're all in the games industry, so we probably know what that's like. So that was a really, really cool thing to do. It was a really trivial thing that we were able to fix. So the results of this, interaction and AI debugging was so much easier, and it really was. We were able to solve complex problems. We were able to solve chaining bugs, all these other things very, very simply. I told you before about a sim that was standing in the middle of nowhere. So the way that our AI system works is that if you are a playable sim, we do not try and send you to other locations. The only other location we'll ever send you to is your home, in case you're starting to starve to death, and you'll go home and deal with that. Other than that, we don't ever send you anywhere. We don't run that form of AI that says go somewhere else. So we had a sim that was basically standing in the middle of nowhere, and I'm like, what is he doing? And so we figured out it's like he's just slightly off of the little lot bounds thing for that particular area. So there was nothing for him to do, and he couldn't go home. He would have to wait until he started starving to death. But he should never actually have chosen to go out there. So it was another type of situation of like, OK, attempted interactions. Let's see what's happening. In this case, he was watching a sword fight. So the way that a sword fight works is that we have two sims, and we place them together, and we're like, OK, I'm going to sword fight you. And then all around there, a radius, which does not respect the lot boundaries, we have different sort of people who then go to watch this sword fight and cheer them on. And so that was what was happening, is it just happened to start a sword fight at the very corner of the lot, and then someone just happened to kind of route just slightly outside of that lot. And so it was a simple fix, which was to sort of fuzzify, if I'm just outside of a lot, why don't I just go back to that lot that I was just on? So it was also an easy fix, but one of those things where it's like, how could he have ever gotten there? And we wouldn't have been able to figure it out without being able to see the history of what had happened. The stuff that didn't work so well, really, and I have one item here of more history. History was something that really saved us and really made incredibly difficult bugs that I've had on other projects much, much, much easier. Again, that same adventure game that I worked on, it was the same type of thing. It was like, why are these triggers not firing? And so you have to dig in there and figure out OK, let's statically analyze the XML of this thing. And that's terrible. So next time we want to build history right into the core infrastructure of the main tool interface that I told you that we're building. And the other thing is we're planning for history tracking on basically everything. So we're basically planning, the core of that is that this time we're planning for history up front. And that is a stated goal of everything that we want to do. We want to track history on everything that matters. So that's very important. See, we are getting close. OK, cool. So to recap, integration, right? Integration is a balancing act. So you have to try and weigh that trade-off between in-engine and standalone. And there are hybrids, and there are other things, and you can mitigate the costs. We mitigated some of the costs, because we're using C# and so on. But generally, an in-engine tool is going to require some kind of custom UI layer, and a standalone tool is generally going to require some kind of communication layer. So make sure you choose what fits with your game. Maybe you don't have a choice. Maybe you're making a console game, and connecting through a network interface might not be the easiest thing to do, right? So sometimes you don't have a choice, but the choice is very important for those who do. And make it as non-invasive as possible. It kills me every time I see gigantic, swaths of pound ifs for every single instance of needing to write to a tool. That doesn't scale. And so for extensibility, your tools need to grow with the project, right? So you want to create some kind of API to be able to modularly add these different tools. It's a sort of core component architecture system. You want to create a toolbox of these widgets and wrap this sort of onion, right? So you have the lowest level stuff, which is like data grid view control in our example. You want to have the next layer up, which is like the tabs that we use for autonomy windows or whatever it is for your particular game. And you want to have the outer layer, which is like the actual template for everything. And so that's really important, and have them conform to some single interface. So for interactivity, You want to make your tools as interactive as they possibly can be, right? So you want to be able to change your game state and try and hit these edge cases as much as you possibly can. So debugging these edge cases is so much easier if you can just tweak your game state right there. If you're like, instead of having to go and find that guy and shoot him in the face, if I can just set a bit somewhere that just, click there, now I've shot him in the face, then that's a lot easier because as an engineer, if I have to spend 10 minutes reproing this thing every time I try and repro it, then my iteration time is going to be a lot, right? I'm going to lose a lot to that iteration time. So for visibility, you want to, so visibility is all about being able to drill down into the thing that you want and be able to find the information that you want. If you have you have like multiple windows to these games, to the world, to your game world. So it's like being in a house with windows all around. You need to know and easily be able to go to the window that you care about. If you have to climb over the couch to get to the window that's looking out over the snowy tundra, then you're not going to be able to debug that very well, which was sort of an odd analogy. So make sure that your tools support things like filtering and sorting and all this other stuff, right? You want to use color. You want to make it easy to view particular objects. You want to be able to allow users to create custom views if they need to. We cheated in a few places where it's like the columns, you can resize them. So some designers, like certain columns that they just didn't care about, they would just resize them to like nothing. And that's fine. That stuff can work. And so history. You want to track everything, right? So history is really the key to understanding how some bad state is occurring. You want to make sure that you're tracking all the objects that are most likely to sort of be in bad states or create these bad states. And track everything that you can in those, because you have no idea where it's going to actually come from, right? And you want to allow the user to be able to walk backwards in this stack, so step backwards and see what's actually going on. So thank you. That is my talk. If you have any, my email address is rez@ea.com, and if there are any questions, there is a microphone there. Also, you should be getting an email like any time now to fill out an evaluation. Please fill that out. Thank you very much.